All right, we are looking at Chapter 8 for exponential algebra. Our topics for this chapter are polynomials and factoring. This is one of those skills that you will see forever and ever and ever. In every math course from here on out, you will be doing factoring. My college algebra students were doing this today. All right, you have to know how to factor. So, Chapter 8 is one of those really important chapters that you don't want to gloss over and say, oh, I didn't quite get that. Hopefully Chapter 9 will be better. Okay? It all builds on these topics. All right, so for today, we're looking at adding and subtracting polynomials. In section 8.1, we're splitting it into 2 days. So today the focus will be the adding part. Tomorrow we'll focus on the subtracting. And we're also going to have some new terms that you need to learn. Okay? So our first term, a monomial. We have several terms actually, monomial, binomial, trinomial, polynomial. A polynomial just means many terms. A monomial would be a single term. Okay? So for monomial, it is one term. Examples of monomials would be just a plain number. It might have a variable with it. It could have powers. It could have several variables like 7x squared y cubed. Those are all monomials. Okay? It's a single piece. Everything in that piece is just being multiplied into one chunk. Okay? Polynomial means many terms. Okay? So a polynomial might look like 2x to the fourth minus 3x cubed plus 7x squared plus 5x minus 1. All right? That's just a really big polynomial. Each of the pieces in there are called terms of it. So wherever you see a plus or minus sign, it is separating terms. So this is a polynomial that has 5 terms. Okay? The degree of a polynomial is the highest power. Okay? Highest power, highest exponent. So when we look at the degree of the last one, this would be degree 4. Okay? Because the highest power that we see for our variable is a 4. Okay? When we write things in standard form, we are putting them in order from highest degree down to lowest. Okay? So you're going to rearrange things. So the highest exponent is first, and then go all the way down to the lowest. So the example I gave you for a polynomial is in standard form. All right? We have our fourth powers, we have our cubes, our squares, our first powers, and our constants. Okay? So how would we rearrange this to put it in standard form? Which piece has the highest exponent? Okay, so the very first one, negative x cubed. So that's going to stay in the first position. Okay? Which term is next? If we're thinking of putting them in order, highest power down to lowest. So we're going to take the x squareds. Now we always, when we move things around, we always take the sign that's right in front of it. So we're going to move this as a positive 3x squared. The next highest power is our x, because it's an x to the first. And our last piece would be our constant, in this case the negative 5. If there was an x on there, it would be x to the 0. But we talked in our last chapter, right? Anything to the 0 is 1. So negative 5 times 1 is just negative 5. So we typically wouldn't write an x to the 0 on there, but when you're thinking about putting it in order, those constants, the numbers that don't have the variables, would be the last piece. Okay? All right, so we're going to look at naming polynomials. I gave you an example of the first one when we called it a monomial, right? A single term. We can name them in two different ways. We can name them based on their degree, and we can name them based on how many terms they have. Okay? Typically, when you're asked to classify a polynomial, they're looking for both. So let's look at our first example. Our polynomial here is just a 6. Okay? How many terms is that? There's one term to it. Okay? If there's just a single term, what did we say it was called? A monomial. Okay? Looking at our second one, 5x plus 9. How many pieces do you see? 2. You have a 5x and you have a positive 9, right? 2 terms. What do you think that one's called? So in our terms that we defined earlier, I gave you a monomial. A polynomial is just built up of a whole bunch of monomials, right? Just strung together. If it's 2 terms, we call it a binomial. Think of a bicycle, right? A bicycle has 2 wheels. A binomial has 2 terms. Okay? How many terms are in our next one? 3. The 4x squared is one term. The 7x is another. The 3 is another. So it's made up of 3 little monomials. Okay? 3 terms. What do you think it's called? If a bicycle has 2 wheels, remember as a child, a tricycle has 3 wheels. Okay? So monomial is a single term. Binomial is 2. Trinomial is 3. Okay? So mono is 1, bi is 2, tri is 3. How many terms in our next example? We're back to 1 term, so it's called a monomial. Our last example? How many terms? 3, so it is a trinomial. Okay? Anything more than that, if there's more than 3 terms, we just refer to it as a polynomial. Okay? It has many terms. So I could reference something, it's being a polynomial with 5 terms, a polynomial with 4 terms. Okay? We don't have special names for anything beyond 3. All right, let's go back and now look at how do we classify them based on their degree. Okay? So in the first one, do we have any x's? It's a plain 6, right? Remember a few minutes ago when we talked about that negative 5, we said it would be negative 5x to the, if there's no x's, it's x to the 0, right? X to the 0. So we would say this is degree 0. There doesn't have any x's. Our next one, what is our highest power? A little 1 there, we don't see it, but we know it's there, right? So that would be degree 1. Next one would be degree 2, right here. Okay? This one is degree 3, its highest power. Last one is 4. Now, the names we associate with those degrees. The first one is called a constant. Okay? Variable means it can vary, it can change. There is no variable on that. So it's constant. Okay? It's going to be a 6 forever. The second one, degree 1, If we were to graph it, what would it look like? If I were to graph y equals 5x plus 9. You spent a whole year on it last year. Right? You did linear algebra last year, right? If you graphed y equals 5x plus 9, it's a line. Okay? It's linear. This year, in exponential algebra, we're going to start looking at higher powers. Okay? Our next one is called quadratic. Its graph is going to be a parabola, kind of a U-shaped graph. How do we read this next one? 2x, instead of 2x to the third, we can say 2x cubed. It's a cubic. Okay. Last one is degree 4. How many, if we split a dollar into 4 equal parts, they would be called quarters. Football game has 4 quarters. Yes? So, degree 4 is a quartic. I'm going to change this. I want you guys to know this. Okay? Beyond that, we have other terms. Degree 5 would be quintic, but for our purposes, anything beyond a 4, we'll just say degree 5, degree 6, degree 7. Okay? Most of the time, you would be classifying things that wouldn't go above that. So, 0 is constant, 1 is linear, 2 is quadratic, 3 is cubic, and 4 is quartic. Okay? Questions on those? All right. It says write each polynomial in standard form, then name it based on its degree and number of terms. All right. So, first thing we want to do, get it in standard form. Which of those pieces is going to go first? Okay. X to the second. Next, we would have the 3x. And we're going to take that negative with it. Okay, so think of it as a negative 3x. And our last piece is the positive 4. So we have it in standard form. Now to classify it, there's 2 different classifications. One based on number of terms, one based on degree. Typically the degree is given first. So this is degree 2. What was degree 2 called? Quadratic. So this is a quadratic. Now, how many terms does it have? How many terms? 3. An x squared, a negative 3x, and a 4. Okay, 3 terms. So it is a quadratic trinomial. Okay. Next one. Which one comes first? All right, 8c to the third. Then we're going to have minus 3c squared. And last, the plus c. Again, make sure you indicate is it a positive or negative. Okay, so plus c. Degree is what? What's your highest power? A 3. So it is degree 3. Because it is degree 3, we call it a cubic. And it has how many terms? 3 again, so a trinomial. So this one is a cubic trinomial. All right, negative 2 minus x. Which one is going to go first? The x piece? So we're going to take the negative x first, and then the negative 2. Okay? What is the highest power? A 1. So we would say it's degree 1, which means we call it linear. And it has how many terms? 2, so it is a binomial. All right. Which one's going to come first? Good. And then the negative 6x would be second? Okay. Now, notice that when we put things in standard form, it doesn't mean we have to have one of every power, right? We jump from an x to the 5th down to an x to the 1st. That's okay. We're still going highest power down to lowest with whichever pieces we have. What is the degree of 5? We didn't have a name for that, right? So we're going to say 5th degree, and then how many terms? So it's a 5th degree binomial. Okay? Questions about any of those? All right. I'm going to read this and I'm going to pause the recording and give you some time to do this. It says, create a polynomial which meets all of the criteria. It is a quadratic trinomial with a lead coefficient of 4. We haven't talked about that term this year. Lead coefficient means what? Let's break it down. What does coefficient mean? Okay, let's break it down further here. Let's go back to this one. The coefficient of x to the 5th is the 7. Coefficient is the number in front of your variable. Okay? The coefficient of the x term is a negative 6. When we talk about the lead coefficient, we're talking about the one that's in the highest powered piece. Okay? So the lead coefficient of this example would be a 7. All right? So in the one I want you to write, our lead coefficient has to be 4. It has to be a quadratic trinomial. The constant term has to be a 3. And the coefficient of your x term has to be a 1. Okay? I'm going to pause the recording as a group, as a table. All right? I want you to come up with a polynomial that works. All right. I saw some great work as groups. Some of you started out looking at it and saying, well, it has to be a trinomial, which means it has to have how many terms? 3. Trinomial is 3 terms. So we know that we're going to have 3 pieces to it. Yes? All right. Then it says it has to be a quadratic. If it's quadratic, that means it's degree 2, right? Quadratic's degree 2. That means my very first term has to be something squared. X squared, y squared, m squared, I don't care. But it needs to be a variable squared. Okay? Then it says it has a lead coefficient of 4. We talked about that being the very first number in your polynomial, right? When it's in standard form. So we know that this has to have a 4. Then it says the constant term is 3. The constant is always going to be at the end, right? Because it doesn't have an x on it. So it's your lowest powered piece. The constant is going to be a 3. And then it says the coefficient of your x piece is 1. Well, there's only one spot for that x to go, right? So we're going to have a 1x as our middle term. Okay? Questions about that? All right. The last part that we're going to look at today is how do we add these polynomials together? Okay? 2 requirements. If we're going to add or subtract, we have to have like terms. We have to be putting like terms together. So for something to be like terms, it has to have the same anybody know? Same variable. I can spell here. Same variable, and those variables must be to the same power. All right. So you would have combined like terms last year, right? So we're looking for those pieces that have the same variable and same power. Some examples. 5p squared plus 6p squared. They are like terms. Both of them have p that is being squared, yes? So 5 plus 6, so we'd say 11 what? P squared. The variable or the power does not change when you're adding. All right? If I add paper clips with more paper clips, I just get a bigger amount of paper clips, right? They're still paper clips. So if I'm adding p squareds with other p squareds, I just get more p squareds. What's the number in front of the x cubed here? It's a negative 1. So think about it. If we have negative 1 and we're subtracting 5 more, we are at negative 6x cubed. Yes? They were both x cubed. All right. How about this? Does the variable part match? And the powers. The first one says we have CD squared. The next one is another CD squared, right? So they're like terms. All we have to do is add the 3 and the 4. So we have 7 of these CD squareds. Okay? All right. So our first example. Typically, when we are adding and subtracting polynomials, we want to put that answer in standard form. It's just easier to do stuff with it when it's in that order. Okay? So, are the two polynomials already individually in standard form? Highest power down to lowest. Okay, so that makes it easier to find like terms. Looking at our x cubes, we have negative 2 of them in the first one, and we have 4 of them there. If we put those together, we get 2x to the third. Okay? Looking at our x's, we have some here, but where are they in the next one? They're over here. What's missing in this first one? There's no x squareds in the first polynomial, right? So if I were putting them in standard form, the x squared should come next. So let's go ahead and move these. We're going to take these x squareds. We don't have any from the first polynomial to add to it, so we just have a single x squared. Okay? Now we can list our x's. We have a negative 1 and another negative 1, which means what? Okay, so we have negative 2 x's, and then our constants are going to come last. We have 3 plus negative 8, so negative 5. Okay? All right. I'm going to pause the recording again. I'm going to give you a couple minutes to jot these down at the bottom of your page. Okay? And try working through them with the people at your table, and then we'll come back and check them. All right. Once again, check to see if they are in standard form already. It just makes finding those matching ones a little easier. So we have a 4, 3. We don't have any squareds in this one. First power, 0 power. 4. This time we have squares but not cubes. First power, 0 power. Okay, so they're pretty much in order now. We just have to make sure we're grouping them correctly. So we have 5m to the 4th and a negative 3m to the 4th. When we add those, we get good. All right. Then next would be our cubes. Our first one says we have 3 of them. Our second one doesn't have any. So we're still going to have 3m cubes. Then our squares would come next. Our second one has negative 2 of them. Then we look at the m's to the first power. We have negative 2 here and 8 here. Gives us a total of 6 of them. Okay. And then last terms, constants. We have a positive 1 there. We have a negative 4 there. Adding together, we get negative 3. Okay. And our last one. They are in standard form, but what's the highest power going to be? The 3's. Yep, we're going to do the cubes first. So I'm going to bring this 7y cubed first. Okay. Then let's look at our squares. We have 3 of them here, and we have -5 of them there. Adding them, we get -2y squared. Our y's, we have -3 of them, -9 of them, and 2 of them. Okay. And then constants. +6 here, +5 there. So we have 11. Okay. Questions on adding them? If I asked you to classify this one, what would we call it? So go through. What's its degree? What's its highest power? Highest power. 3. So we call it a... So it's really easy to get the 2 different classifications mixed together. The nomial ones, right? Monomial, binomial, trinomial, polynomial. That's counting how many terms there are. The constant, linear, quadratic, cubic, quartic. That's dealing with the degree. Okay? So this is degree 3, which means we call it cubic. How many terms does it have? In its condensed, added together, combining like terms, right? There's 4 pieces. So we say it's a cubic polynomial of 4 terms. Okay? Questions about that? All right, I will get your worksheet out to you.